introduce you the study analysis of fixed width binary method. The relevance of this work. Rock curve analysis in machine learning is used to select the best for a given dataset classification algorithm. The rock curve analysis is applied in areas medicine, finance, and economics, information retrieval, quality control, and others. However, rock curve construction imposing on predicted binary probabilities at threshold 0.5. It means that for positive values of a target class, a predicted probability must be more than or equal 0.1. Such threshold is applied on the probabilities which are predicted only by a logistic regression classifier. Other commonly used classifiers compute probability differently, such as random forest classifiers predict probabilities, sometimes called scores, as a fraction of samples in a given class within the set of a decision tree. Naive classifiers compute the probability data probabilities with which data points belong to a particular class based on a Gaussian distribution for the feature. And support vector machine classifier does not provide probability. Instead, for each data point, it calculates the distance from it to a hyperlapse. Therefore, classification of predicted binary probabilities are needed to be calibrated in order to be used with the curve analysis. As a benchmarking method to calibrate binary scores is used a histogram binding method that was proposed and proved as efficient for algorithm random forest classifiers and bias classifiers. The method is called fixed width binding, and according to this method, the interval from 0 to 1 is partitioned into bins, and number of bins is a constant. It is a 10 number. The computation simplicity and ability to measure a calibration error for this method made it often used. However, the method is effective when bin number is properly selected, as depending on dataset characteristic, predicted binary scores are differently distributed through bins, and too small or big number of bins could cause calibration scores are either over detailed or over smooth. Below you can see an illustration of over smooth scores that can reduce the area and the rock curve by 2 times, which may unexpectedly impact the rock curve analysis results. Then other studies related to fixed width binding method results that was proposed scaling binding method. The algorithm divides data into 2 subsets. The first subset is calibrated by other continuous calibration method called plot calibration, and the second subset is used to choose the bin so that equal number of points are landed in each bin. The scaling binding method addresses 2 issues: reduce calibration error, calculates bin width, which is adopted to already calibrated scores. However, plot calibration method has a few problems. It is the most efficient when distortion of predicted score is sigmoid shape. It is computationally intensive as it is solving a convex optimization problem to find sigmoid function parameters. Objective for this study, the current research objectives are to empirically study and prove that a fixed width binding method to scale binary probabilities with 10 intervals may lead to inconsistency between the rock curve analysis results received on rock curve constructed with uncalibrated scores and rock curve constructed with calibrated scores, and to recommend a direction on how the inconsistency to be avoided. Our methodology used in the research is the following: construct rock convex hulls for unpredicted and unscaled and scaled predicted probabilities. Compare classifiers' performance based on root curve analysis and record the differences. If the differences are found, then research for the reason by analyzing the algorithm for rock convex hull construction. And the materials we are going to use for experiments is the following. Rock curve depict relation between true positive rate that is calculated as a fraction between positive instances correctly classified to a total positive instances and the false positive rate, which is calculated as a fraction between negative instances incorrectly classified to total negative instances. True positive rate is plotted on y-axis and false positive rate on x-axis. And this enables to perform the analysis in order to select the value for probabilities threshold, which will guarantee a certain classification algorithm performance. And to construct a curve is used an algorithm that is presented on this slide. It specifies a sequence of steps which are required to construct the curve. As input, it takes probabilities, denoted here as a calibrated scores, predicted classes, and number of total positive and negative instances in the data. In line number 1, algorithm sorts input dataset according to probabilities in descending order. In blocks from 5 lines 5 till 13, it's repeated for each predicted class and include the following. If calibrated scores or if simply scores on current iteration does not repeat the score on previous iteration, then add to curve hull the increment on x or y axis. In line from 9 till 10, in each iteration, the increase is calculated on y-axis if calibrated scores is positive. Otherwise, the increment is calculated for x-axis. Our input parameters for experiment is presented in table 1. So for 10 positive and 10 negative instances, we specify a predicted class with corresponding uncalibrated binary probabilities. The probabilities from table 1, after calibrated with a fixed width binary method with 10 bins, are included in table number 2. From table number 2 is visible that probability which are in the same bin have received average bin score, which means equal bin score. And here is an illustration of row curves created, constructed for uncalibrated probabilities and calibrated probabilities. Average score impacted a row curve hull. As a result, on picture A, threshold equal to 0.5 shows 7 positive instances which are predicted correctly and 3 negative instances which are predicted incorrectly. On picture B, the threshold 0.4 is needed to achieve similar classifier performance. As a conclusion, in this study, it specifies that scale predicted probability with fixed width binding and 10 intervals may become too smooth, in other words, got assigned equal values. The logic of rock curve construction algorithm removes duplicate and sorted list of calibrated scores, which changes rock convex hull, and the change in convex hull cause inconsistency between rock curve analysis result received with uncalibrated binary scores and calibrated binary scores. To avoid the mentioned impact on rock curve, it is recommended in current study to calculate number of bins dynamically before calling fixed width binary. Based on we need to consider the statistics of a predicted binary uncalibrated scores while choosing the method for identifiers in the number of pins. Thank you for your attention.